So when I started doing this around 1995, we set out to ask this question of whether there's a part of the human brain that's specialized for face recognition. And so you guys are already in a position to consider, even aside from the functional MRI data, I'm sure you've seen some of it, but even if you'd seen none of the functional MRI data, what would you guess based on the kind of things from the first half of my lecture? Yes? Necessarily? Is it already like completely known, like we don't even have to look because it had to be in there? Good assumption? No?
No, it might process in a different way. Like face processing might be different, area might be the same.
Yeah, it's not a foregone conclusion. We showed all these ways that face processing is qualitatively different from processing of other things, but that doesn't necessarily mean it's a different piece of the brain. It could be either a different set of neurons that are interleaved at a fine grain, or the same set of neurons that just do two different things, right? So it's a good bet. It's definitely worth looking based on the behavioral data, but it isn't clear yet from the behavioral data alone, right? You want to do neuroimaging experiments where there's a reason to think there might be a dissociation. But you can rarely tell from simple behavioral data alone that there will be. I mean, there was other evidence before we got to this that made it pretty clear there probably was such a region in the brain based on studies of patients with focal brain damage who selectively lose their face recognition ability and don't lose their recognition ability with object recognition. So there was reason to think that such a thing was in there, but it wasn't yet fully clear. Okay, so what do? We did this very simple experiment. We popped subjects in the scanner, we showed them pictures of faces, and we showed them objects, and we scanned their brain while they were looking at these things. Okay, and then we get the stack of images through their head every 2 seconds, and we take, for each voxel, we ask whether the magnitude of the MRI response in that voxel was higher during the periods when subjects were looking at faces than during the periods when they were looking at objects. Okay, does that all make sense? And when you do that, here's the kind of thing you see. Here's a subject, a slice of their brain near the bottom of the brain. This is the back of the head. These are their ears sticking out here. Left and right are flipped here. And what the color is telling you, the green is an outline, but inside that, the yellow and blue, is telling you that the statistics are saying that the MR signal was stronger for faces and objects right there. Okay? It's very useful to not just believe a blob, but to actually see the data that produced the blob. So here's mine. So this is the 5-minute scan here, and you can see that those voxels right there produced a substantially higher response during the time this person was looking at faces than when they were looking at objects. Everybody see that? Now you can also see in blue, we had people just staring at a dot, right? You can't turn your visual system off, but the way to damp it down as far as anybody knows how is to stare at a dot in an empty screen. That's about as off as your visual system can go, right? And so that's this blue mark here. And what you see is that part of the brain responded more to objects than to staring at a dot. It just responded a whole lot more to faces than objects, okay? So when I talk about face-selective regions of the brain, I don't mean regions that are completely silent, where no neurons are firing at all when you look at objects. I just mean regions that like faces a bunch more than objects, okay? Okay, so that's one subject. How systematic is this? Here's a really old slide from our first study. Here are 12 subjects, that's me in the upper left. And you can see quite a bit of variability across subjects and exactly where that thing lands. But in approximately the same region, almost all subjects have a little blob that responds more to faces and objects. Okay, you got that? Okay, so now we have this. Now the question is, does this result here demonstrate that the brain contains a region specialized for face recognition? Any one contrast like that, this is actually a really sloppy contrast, faces and objects, oh my God, they differ in 100 ways, right? But even a very carefully designed contrast usually has other accounts. So if you really want to nail the function of a region, you just need to keep testing it, right? So let me give you an example of how we've done that in early work. So some of the things that we worried about are, maybe it's about visual attention. We're social primates, as I started off saying. We care more about faces than toasters and coffee cups, right? And so maybe we're just more attentionally engaged when the faces are on than when the objects are on. Or maybe it's not just faces, maybe any human body part would engage that region, right? Maybe it's specific to some views of the faces. Maybe it's only front views of faces, not profile views. Then it wouldn't really be face perception, it would be front view face perception. Maybe because faces are all different exemplars of the same basic structure, we have special machinery for discriminating exemplars of the same basic kind of thing. You see what I mean? And on and on. So there's an infinite number of these things. And you can't test the whole infinite number, but what you have to do is consider the whole, think about it hard, come up with all the ones that seem like plausible alternatives, and test them. Yeah? So we've been doing that for a while, and let me just give you an example of how we do that. We say, okay, let's take this question. Is that face region just greater visual attention, greater attentional engagement by faces and objects? So what we do is we find that region in each subject individually in the way I just showed you, do the face versus object contrast. The reason that's important is that it lives in a slightly different position in each subject. So if you just mush all the brains together and take a guess, you're not going to find it. So find it in each subject and then test it. Okay? So we find it, and then we test it on some new experiments. So here's one, for example. We showed a bunch of 3/4 view faces with no hair showing because they had a hat. And we showed a bunch of hands, okay? And the task was a one-back task. That means you press a button whenever 2 consecutive images are identical. And by design, this task is perfectly doable, not very hard with faces, and damned difficult with hands. We wanted it to be really hard with hands. We wanted subjects to pay more attention to the hands than the faces because we're testing the attention hypothesis. We wanted more attention on the hands. So we made that really hard, okay? And here's what we found. Okay, this is the data I showed you before. Now, having identified that region, we can ask, what does it do in this new experiment? And here you see, here's the response to hands, faces, hands, faces, hands, faces, in the same region that responds more to faces and objects. So now, with this one experiment, we've knocked out a whole bunch of things. It's not just visual attention. They were attending more to the hands. It's not just any human body part. It responds more to hands. It's not just front views of faces. It generalizes to 3/4 views. It's not just any fine-grained discrimination of things of the same category because the control was hands, et cetera. Right? So by clever experimentation, you can just go at each of those alternatives and test them. Okay? So we did that for around a decade. And here's a summary slide. And we basically ruled out pretty much all of the alternatives, the obvious ones that anybody would come up with. And the thing is just very specialized for face recognition. It's just a fact at this point. So I'd say what we know now is this region is strongly selective, at least twice the response to faces as anything else that's been tested. It's present in essentially every normal subject. This is just part of the basic anatomy of the human brain. And there are just a million fundamental questions one wants to answer about it, most of which are not answered. And I'll end with one really important one I alluded to earlier. Functional MRI is wonderful in this kind of way that you can identify pieces of the brain, which I think also correspond to pieces of the mind. That's why I care. And that's a very fun enterprise. But it has fundamental limitations. And one of the most important limitations is that you can't test the causal role of those regions. So even with all of this work, we don't know that if you lost that part of the brain, you would lose your face recognition ability. Or that if you messed with that part of the brain, you would affect face recognition. Okay, so that's a very important question you can't answer with functional MRI.